Hello everyone, thank you for joining us in this lesson. So today we are going to talk about methods, associated functions, and structures. Picking up from where we left off, we created a very basic program here that has a structure called student. It reads the student name and age from the terminal, and then it adds it into this vector, and at the end it just prints the entire list. Let's make this more interesting. What if we create a class? And then within that class, let's say it's a computer science class, you want to add multiple students with their relevant scores. Since we are already familiar with structures, we are going to create another structure called class. And then we're going to add methods to the class itself. Of course, this is classes in the classroom and not to be confused with the object-oriented term called class. Methods are quite interesting in Rust. They are essentially just function that sits within the structure itself using the implement keyword. The only difference between the methods and your generic functions that you see is that methods usually have self as a first argument, and think of self as the this keyword from Java or C++, for example. The other type of function that you will see within struct is something called associated functions, and these are functions that are not necessarily tied to the instance that you've just created, but they're tied to the struct. Think of these as your static methods from your object-oriented language, your favorite one, and I'll show you an example of how to do this as well. Okay, so without further ado, let's start coding. We will look at our student class first and add an additional field here called score. And this will basically just records the score of a student in a certain field. We'll make it generic for now. Of course, if you want as homework, you can go ahead and elaborate on this as much as you want. Okay, next thing, we need to create a class struct. Again, not to be confused with class as in the object-oriented term. Now in this class, I'd like to have the name of the class, for example, computer science or multimedia, something along these lines. And then I want to have a vector of students, essentially a list of the students that are enrolled in this class. And then we'll do some interesting methods later on. Okay, so far we've got two structures, student and class. I mentioned methods earlier, so let's start implementing our first method. This is the keyword to start implementing methods. And I'm going to choose class here. And then let's start maybe with calculate average score for all the students in this class. So remember, the first parameter in this method needs to be the self. Since I don't have anything else, I would just get it to return an integer as your average score. Let's just get this done quickly. Now this is the variable that's going to hold my average score. It's going to get all the scores from the students vector. So we've seen all of this earlier, right? So we're just iterating through the vector, and then we are incrementing the average variable here. Then we'll close the actual for loop. And at the end, we just divide by the length of the vector, which is basically the number of students that are enrolled in this class. Now remember, if you recall, I think from lesson 3 or lesson 2, we talked about the difference between usize and integer types. So we have to divide by the same type. .len, as in the length of the vector, returns a usize. We need to cast this into an i32. Now we have created our first method. Let's try it out. But before we do this, we're going to have to modify the code that we've written previously. There is some extensive cleaning up to do here. I'll tell you what, let's leave the vector where it is right now at line 27, and let's create a mutable class variable. And I'm just going to call this class name computer science and just convert that to a string type as opposed to the literal string, and then I'm going to give it the vector variable. Okay, let's see here, it's complaining about something, has no field named vector students. Yeah, of course. So we're going to have to modify that, and let me see what I call it there, students. Okay, students. We are going to use this loop, and maybe we can modify this loop. Let's do something more interesting here. Max entry, so I only want a maximum of 10 students here. And we'll use the while, so we can just limit the number of students that are getting entered into this class. So while max entry is greater than 0, and let's decrement it here at the end of the while loop. There you go. So bear in mind here, I do need to declare it as mutable, just so I can go ahead and modify this. Right, and then the reason why I did this, so I can just reuse line 31, 32, 33 in fact, all the way to, yeah, I can pretty much use all of them. Let's try and do calculate average. Okay, and let's print this. Average score for class is out of 10. What we need to do here is now parse score, right? So in the terminal, we do need to add 3 fields. We need to add the name, the age, and the score. So we do need an additional field to parse. Line 34, we should have a vector array of 3 items. So our assert at line 35 will make sure that happens. Let's add score here as an I32. Let's get answers, and we'll do the same thing as we did in line 37. So we trim, we parse, and then we do unwrap. Okay, and then line 39, we'll just do score. If you recall, if you already have a variable called score, then you just leave this field as is, and it will automatically fill it in. Basically, you don't have to do this again this way. Great. So we don't need the println at, or maybe we do need it. Let's leave the println at line 40 here, just to confirm what we've just typed in. Tell you what, so let's take line 28 here and put it outside the loop. Let's take the final message about average score and take it outside the loop, because of course this would only happen after we completed the data entry. Let's format our messaging properly. So line 39, you entered student name and age and score. So let's add the score in there, and score, let's grab that. Student score, because we just passed it, right? Okay, let's delete this empty space, and then we'll just use some formatting here to make sure it's nicely formatted. Let's make sure why this is happening. Of course, I need my placeholder here. Okay, I've got the vector at line 49 that pushes the student that I just gleaned from the terminal, right? So that was just a data entry, and then I'm looping through the vector array of students. I'm just printing their name. To be honest with you, for now, maybe we don't even need this, so let's just delete it. Okay, and then of course this max entry will decrement every time the loop goes through. Once the loop finishes at line 52, we'll create the class with the computer science as a name. We'll assign the vector of students to it, and then we'll print the average. Okay, yeah, I think that's a good program to start with, right? So you'll see here the methods that we've created. You'll see it how it's going to work. In fact, before I run it, let me just reduce the size here so it fits nicely into the screen. And we'll just do cargo run. There you go. There's a lot of warnings. Of course, we can fix that later on, but for now, let me see. Please enter the student name, age. Okay, we forgot to add the score text here, but that's fine. In fact, let me just fix that real quick. Okay, let's run it again, nice and tidy. Okay, I'm going to put John, age 12, I will put 10 out of 10 because this is how we're measuring the score for John. Okay, in fact, let me just copy this because it's going to do it 10 times, right? So let me just, it's going to prompt us 10 times. Do the same thing, 10 times. Okay, there you go. And then it says average score for the class computer science is 10 out of 10. So you've got a cohort of excellent students here. And let's see what else we can optimize. So at the moment, we are adding the students manually. I mean, it's fine, but we can probably do with a better method. Let's add another method here. And I'm just going to call it add student. I'm going to give it immutable self. That way I can modify that. And I'm going to give it a parameter. It's called student. And then it does not return anything. I don't want it to return anything. And then from here, I can just use my students vector to start adding students. Moving the definition of class to line 32. That's great. And then at line 56, instead of manipulating the vector directly, I'm just going to call my class add student method. Again, if you have a variable that is named similar to the actual argument of the function, then it's fine. Okay. Clear the screen. I'll go run. There you go. Again, let's try John 12 and then with a score of 10. We'll do that 10 times. Okay. There you go, computer science, and the score is 10 out of 10. I just spotted something here that we can fix real quick. Let me just close the terminal. As you can see here at line 44, we're not using the variable name. Instead, at line 48, we're taking the entire buffer, which essentially is the entire line for student name, age, and score, and storing it into the name field. That's incorrect, so we need to remove that and use the name here, or in fact, we don't even have to, right? Okay, we don't have to, of course, because as I mentioned earlier, Rust will automatically assign this variable to this field, providing that it's got the same name. Okay, let's run it again just to make sure. that 10 times. Great. So our program is coming on nicely. Let's do another function within the structures that we've created. So we've seen methods like the one you see here, add students and calculate average score. Now let's see associated function. So if you recall, we mentioned earlier that associated function, they act on the overall class itself, not on the instance of that class. If you're coming from Java or any other object-oriented programming, you're probably familiar with static functions. Think of this as a static function. Of course, associated function, there's a huge difference between methods, is that it does not take the self as the first parameter. Let's do an interesting function, maybe one that just returns an instance of class. So I'm going to call it create class, and I'm going to give it more or less similar parameters. I want the string name, and then I want the students, which is a vector of students type. Okay. The return type here, I'd like it to be class. And then all I do is such, call it name, and then students. Okay, so that's pretty much it. We now have what we call an associated function. All this will do is return a brand new instance of class struct. Let's try and replace line 37 here. This is very verbose, right? So let's try and make it more interesting. All I'm going to do here is keep the class keyword there. I'm going to use create class associated function. For the name, the same values. So computer science, and the vector called students, and then I'll close the parentheses like such. There you go. Now this is going to return my class. So if we don't do anything else and just execute this program, it should run successfully. Let's give it a go. There you go. So John 12, score 10. Let's copy that. Do that 10 times. There you go. Class is computer science, and the score is 10 out of 10. As a final task, let's try and tidy up this program. As you can see, there's a lot of warnings here, so we definitely need to remove these, especially before we go into production. So let's start with the first warning here. It's complaining about the fact that this default library is not being used. Let's try and see. Okay, tell you what, in fact we can use it. We can eliminate the warning and also make the code a little bit more readable. So two birds with one stone. Since we're importing it anyway at line 1 here, right, we might as well not call the full namespace like we were doing earlier, and instead just use the shorthand here. Okay, so that's done. Let's see, what's the second warning? So saying they should not be mutable, of course, because we're not using it in that way. If you recall, an earlier version of this program was using that vector array in such a way. What else can we do here? Let me just format it a little bit more. It's nicely formatted. Let's try, instead of running it, let's just try and build this and see what happens. Okay, brilliant. So there's no warnings. Is there any other optimization that we can do here?
Maybe we can struct type the variable at line 34 and put the type of the vector to be a vector of students.
Okay, let me just minimize the code here so you can have it all in one page, more or less in one page. Okay, so all we did is declare the student struct, declare the class struct, and then we did the implementation for the class structure, we added two methods, calculate average score and add student method, and then we create an associated function that just returns an instance of that class. And then from here we started looping and getting the details of the 10 students that we want for this class, and reading that data from the command line, parsing the data, and then adding it to the class itself. And at the end, all we do is print the class name and the average score for that class. Thank you so much, everybody, and I will see you on the next lesson.